Hello everyone, myself Ankit Khandelwal, Assistant Professor from the Department of Faculty of Computer Engineering, Pune University. The topic of today's discussion is about the Internet Protocol, that is version 4, IPv4. So let us begin with the topic. The topic contents are as follows, that it contains the introduction about the Internet Protocol, what is the use of Internet Protocol in the Internet. Then we have an IP address, notations, how to identify the valid and invalid addresses. Then we have a conversion procedure for how to convert a binary format of a IP address into a decimal format. Then we will discuss about the classes of IPv4 address. Mainly there are 5 classes. We will deal in that topic there. Then we have a conclusion and references for the particular this lecture there. So the objective of this particular lecture is to understand the concept and importance of IP addressing in computer networks. The students will be able to explain the structure and different representation of IP address, identify valid and invalid IP address based on predefined rules. We will discuss how to convert IP addresses between different formats such as binary and decimal, and then we will also see the classification of IP address into different classes and understand their usage. Now, after completion of this particular lecture, the outcomes of this lecture will be that a student will be able to define the concept of an IP address and its significance in networking. We'll be able to identify valid and invalid IP addresses based on the predefined rules, perform conversions between binary, decimal and dotted decimal representation of IP address, and we will be able to classify IP address into different classes, that is A, B, C, D and E, and understand their application. So the Internet Protocol is having 2 versions, that is IPv4 and IPv6 there. Now this particular 2 versions are having this is of IPv4 is of that is 32 bits there, and IPv6 is of 128 bits there. The first basic difference between these 2 versions are that. Now the Internet Protocol switching at the network layer in the Internet uses the datagram approach to packet switching there. So when the data from the upper layers come to the network layer, the data is converted into the packets, and then these packets are transferred to the receiver by choosing a different paths from the router there. That's why the packets which are reaching to the receiver will be not in order also, and will take some delay part also there. So the communication at the network layer in the Internet is connectionless. That is the communication which we are doing with the receiver through the Internet Protocol is connectionless. And this IPv4 is the delivery mechanism which is used in the TCP/IP protocols there. So with the effort to deliver the packets in a best way, the IPv4 is having an unreliable service, because the packets can be lost. Packets are out of order, because all the packets are not dedicated to a one path there. They are coming from a multiple paths. That's why the packets may deliver out of order. Duplicate packets can be delivered, and packets can be delayed for a long time. So these are the disadvantages of this Internet Protocol, but still they are providing a best effort for delivering the packets in the Internet domain that we have. Now, as we are going to have a discussion on the IPv4 address there, okay. So as I told you that IPv4 address is of an 32 bits, and this address is uniquely and uniformly defines the connections of our devices. That means when you are connecting a computer to a router or a computer to computer to the Internet, we need an IP addresses there. So it's a 32-bit long address there. So 2 devices on the Internet can never have the same address at the same time there, okay. So if we talk about the total address space which we can make using the 32 bits is 2 to the power 32, which is approximately equals to more than 400 billion addresses we can make by using the 32-bit address there. So the notation for IPv4 address is two types of notation. One is the binary notation, okay, and another one is the dotted decimal notation there. So this is a binary format of a IP address in a 32-bit. So this binary notation is can be written in a decimal dotted notation in this form, that is 117.149.29.2. This is the IP address of the above decimal of above binary format there. So the notation of IPv4 address, we have 4 octets, okay, we have 4 octets, that is this one is an 1 octet, this is another octet, this is another octet, this is another octet. Now see this binary format of the IP address, we have 8 bits, 1 2 3 4 5 6 7 and 8, then another 8 bit, 1 2 3 4 5 6 7 and 8, then another 4 bits, 1 2 3 4 5 6 7 and 8, then another 4 bits, these are 4 bits. So total we have 32 bits and each segment is having an 8 bits there. So the range which we can have in a 1 octet is 2 to the power 8, that is 256, okay, that is total numbers will be 256, and the values which A, B, C and D can take is from 0 to 255. So if we talk about dotted decimal notation, the range of the dotted decimal notation for an IPv4 address is starting from 0.0.0 to 255.255.255.255. These are the notations how we are writing this IPv4 notation there. Now let us take an example of some valid IP addresses. The first is 10.10.56.8. This is a valid IP address because all the numbers are in between, that is 0 to 255. Now second example, 192.168.1.234, again a valid IP address because all the numbers are having, that is A is having values in between 0 to 255 and 255 there, and for this particular A we have assigned the value 192. Similarly B is having 168, C is having 1 and D is having 234. In the last slide I showed you that how to write a decimal dotted notation, that is A dot B dot C dot D there. So all the values are in between 0 to 255. The third example, 100.200.3.67, again a valid example of an IP address, and the last address 33.33.33.33, again a valid IP address. Now let us see some examples of invalid IP addresses there. So the first example is having 556.1.2.3.4. So this is an invalid IP address. Why? Because there are 5 octets, okay, 5 octets we have written over here. So this is an invalid IP address because IPv4 is having only 4 octets, okay. Now next example, 89.056, that is 234.12, again an invalid IP address because a number cannot begin with a 0 there, okay, that is that's why it is an invalid IP address. Third example, if you see 200.192.256.6, although it is having a 4 octets, but again it is an invalid because there is a number 256 in this, okay. So again only the numbers from 0 to 255 can be there, okay, numbers from 0 to 255. Now let us now discuss about how to convert a binary IP address into a decimal format there. Now for this, the first analogy which I am going to take over here is, we are having an 8 bits in an every octet. So we are assigning indexing with the base 2 there. Why? Because this is a binary number, and in binary only there are two numbers are there, that is 1 and 0. So this particular bit, that is if we talk about this particular bit, this bit is having 2 to the power 0, this is having 2 to the power 1, 2 to the power 2, 2 to the power 3, 4, 5, 6 and 7. Okay, so 2 to the power 0 is equals to 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 5 32, 2 to the power 6 is 64, and 2 to the power 7 is 128. Now let us take an example. In this example, what we are doing, we are converting the IPv4 address from a binary to dotted decimal notation. So how we can convert it? This is a 32-bit binary address. We will take from this extreme light position 8 bits there. So the first 8 bits, 1 0 0 1 0 0 1 there. Okay, so these are total 8 bits. So if you will look on these particular 8 bits, let me show you that these total 8 bits, if you will see, so this is an 8 bits, that is 1 0 0 1 there, 1 0 0 1 0 0 0 1 there. Okay, so these are the 8 bits. Now how to convert this particular? So in each where there is a binary bit, we will multiply with this its power there. Okay, so 1 multiplied by 1. Okay, so 1 multiplied by 1 is 1, plus 0 multiplied by 2 0, plus 0 multiplied by 4 0, 0 multiplied by 8 0, plus 16, because we have a 1 over here, then we have 0 multiplied by 32, so we will add 0 to this number, plus 0 into 64 and 1 into 128. So you will see that we are adding the only numbers where the binary format is having a 1. So we are going to add 128, 16 and 1 there. Okay, so 128 plus 16 plus 1, that is 16 plus 1 is 17, and 17 plus 128 is 145. Okay, so the conversion of this binary, that is first 8 bits, is equal to 145 there. Similarly, the second octet is having a values, that is 0 0 0 0 1 1 0 1 there. Okay, so now let us convert this particular number into again decimal format. So as I told you, where you are having a 1 in the binary format, you will multiply that particular power into a consideration. So 1 into 1 1, okay, 1, plus I have 1 over here, so 1 multiplied by 4, plus 1 multiplied by 8, plus 0, all are zeros there. So the number will be 8 plus 4 12 plus 1 13. So the binary conversion of this particular 8 bit is equals to 13. So till now we have identified the first octet, which is equals to 145. Then second, which is in the green color, is having a decimal number equals to 13. Then moving towards the third octet, the third octet is having 0 1 0 1 0 1 0 1. Okay, so again we are going to convert it into a decimal format. So 1 plus 1 into 4 plus 1 into 16 plus 1 into 64. So I am adding just those numbers where in a binary format there is a 1 there. So 64 plus 16 is equals to 80, 84 plus 1 80, 5. So the binary to decimal conversion of this 8-bit is equals to 85. So now we are having 145, 13 and 85 there. So now the last 8 bits are 00, 10, 11 and 11 there. So again we are going to have convert it. And how we are going to convert it? Where there is a 1, we have to multiply those powers and we have to add them. So 1 multiplied by 1 equals to 1. 1 multiplied by 2, 2 plus 1 multiplied by 4, 4 plus 1 multiplied by 8, 8 plus 1 multiplied by 32, which is equals to 40, 44, 46 and 47. So now we have all the binary to decimal conversions. These are 145, 13, 85 and 47 there. Okay, so how to write this binary dotted decimal notation? That is binary to decimal dotted notation. IP address is 145.113.85.47 there. Okay, so in this way you can convert a binary to decimal notation there for an IP address here. Now the next part of the IPv4 is about the classes. So you will see this particular diagram. The whole address of the IPv4, which is of 32 bits, okay, which is of 32 bits, equal to 2 to the power 32 addresses we can make there, no? Right. So 2 to the power 32 addresses we can there, which is more than 4 billion addresses. These all addresses we have converted into a classes. So there are total 5 classes: class A, class B, class C, class D and class E. Okay, so how we will identify that which IP address belongs to class A, which IP address belongs to class B, class C, class D and class E. So before that you should know that only these 3 IP address, that is class A, class B and class C, is available to the users for doing for assigning an IP addresses to their devices there. The next 2, that is D and E, are not, we cannot use them. They are used for the class D is used for multicasting. We are using for multicasting there, and class E is used for doing an experiments. Okay, experiments or some research works we can do with the class E there. So we are going to use only the class A, class B and class C IP addresses for assigning the IP address to the devices there. So how to recognize that this particular IP address will belong to class A, class B or class C? So you have to see only the first octet, that is first byte. Okay, we have to see only the first byte. The first byte is having 8 bits: 1, 2, 3, 4, 5, 6, 7 and 8. Now if we are dealing with an IP address of an class A, you have to see only the first bit, this bit. Okay, this bit of an first octet. If it is 0, if it is 0, this is an example of class A. Okay, if this particular octet is having 2 bits, that is 1 and 0, this is of an class B. If it is of 110, then it is of a class C. If 1110, it is of class D, and 1111, then it is of class E there. So please be remember that we are just talking about the first octet, that is A. Okay, we have written the IP address in a format of A.B.C.D there. So I am just talking about this A part. Okay, this A part. If the first bit of the A is only 0, then it belongs to class A. If the first two bits of the class of the octet A is 10, then it belongs to class B. If the three bits are 110, then it is of class C. If 1110, then it is of class D. 1111, then it is of class E. Okay, so this is for the binary notation. Now how to identify with the dotted decimal notation? So as you know that the 0 is assigned for the class A. Okay, now we are remaining with 7 bits. Okay, these are the 7 bits there. So if these 7 bits are 0 0 0 0 0 0, then if we convert this into a decimal notation, this number will be 0 there. Okay, so there is a 0, and last address, if we talk about, it is 0, then there can be a 1 in all the remaining bits there. 1 1 1 1 and 1. If we convert this particular binary notation into a decimal notation, this will come out to be a 127 there. Okay, 127. So that's why the class A IP address is having the values from 0 to 127 in the first octet. If you see those numbers in between these two, 0 to 127, this belongs to class A. Similarly, for the class B, the numbers are between 128 to 191 there, and for the class C, it is 192 to 223 there. Again, remember that we are just talking about the first octet, not for all the octets, just talking about the first octet, that is the A value, the value of A. Okay, those values. Now for the class D, the numbers will be from 224 to 239, and for the class E, the numbers will be from 240 to 255 there. Now these classes are saying something about the network ID and the host ID. As we have seen that the class A, the first octet tells us about the network ID, and the remaining 3 octets tells us about the host ID there. Okay. Similarly, in a class B, the network ID is defined by the 2 octets, and the 2 octets define the host ID in the class B. In the class C, the 3 octets, that is A, B and C, will define the network ID, and remaining, that is last octet, which is D, will be an host ID there. Class D, as I told you, is used for multicast addresses, and class E is reserved for doing an experiment or research work there. Now let us come to further there, class A. So this IP address class is used when there are a large number of hosts there. Okay, in a class A type of network, the first 8 bit, also called first octet, identify the network, and the remaining have 24 bits for the host into that network. Now see, this first octet, okay, this first octet is total having 8 bits, and out of these 8 bits, the last most significant bit, MSB, is assigned the value 0 there. So this belongs to class A there, and remaining 7 bits are used for the IP address for the network, to identify the particular network, and these 24 bits are used for the host, assigning the host addresses to the particular network there. So with this, if you will see there, the range which we are having, that is from 0 0 0 0 to 127.255.255.255. okay, so this is the range for the class A, and the first bit starts with 0 there. Okay, so this particular class A is reserved for very large networks, that is a network having a large number of hosts. For that purpose we are using the class A there. Now example, 10.0.0.0/8. This /a, it is used for the subnet mask there. Okay, we will talk about the subnet mask in the next lecture, but for the time being, subnet mask is used for identifying the neighbors in the network there. So in this case, the subnet mask is 255.0.0.0 there. Okay, now let us talk about that how many number of hosts and how many networks are there. So as we are seeing that network in total networks, okay, we are talking about total networks in class A. So total networks, the network is identified by the first octet, which is having 8 bits. Okay, 1 2 3 4 5 6 7 and 8. Out of these 8 bits, the most significant bit is assigned 0. This will not going to be changed. Okay, now we are left with total 7 bits. Okay, we are now left with 7 bits. These 7 bits can have all zeros, 0 0 0 0 0 0, and the last address can have all the values 1 1 1 1 1 1. So this is network address 0 and this is network address 127 there. So you are seeing that total range for the network is from 0 to 127 there, which is equals to 128. So there are total 128 networks there. Okay, but you have to remember that from that is the particular which we are saying is that we cannot use the initial address and the last address for assigning the IP address. Okay, just remember that we cannot use the initial address, that is 0, and the last address 127 for assigning the IP address to the devices in class A. Right, now let us talk about the total number of hosts. Now the total number of hosts are can be identified with the help of these 24 bits. So we are now having 2 to the power 24, 2 to the power 24, which is approximately equals to 1 near about 16 crores host can be there. Okay, so 2 to the power 24, again the initial and the last address will be not there, so 2 to the power 24 minus 2 there, these total number of hosts 2 to the power 24 minus 2 hosts are there, total number of hosts. Okay, why I am doing this minus 2? Because as I told you, the 0 0 0 up to 24 zeros and these 24 ones cannot be used for the IP address. That's why 2 to the power 24 are the total address by including these 0 and 1s, but we cannot use this 0 and 1. That's why 2 to the power 24 minus 2 there. Okay, now next we are having a class B. So in a class B, we know that how to identify the class B, that we have to see the first octet. This is the first octet. Okay, the first octet will be having 2 bits, that is 1 and 0. This is going to tells us about that this is a class B IP address there. So now if you will see this 1 0 is fixed, now we are remaining with 6 bits, 1 2 3 4 5 and 6. So if I assign all the bits zeros to the remaining 6 bits, this is going to be a decimal number 128. Okay, you can see the in the previous slide I have talked about how to convert a binary notation into a decimal notation for an IP address. So this is a 128, and similarly these 2 bits will be fixed and the remaining 6 bits 1 2 3 4 5 and 6 can have all the values 1 1 1 1 1 and 1. So this number will be, if you will convert it into a binary to decimal, then this will come out to be 191. So that's why we are having a network ID starting from 128 to 191 there. Okay, so total address now can be from 128.0.0.0 to 191.255.255.255. Okay, this is the range of class B there. Now again, as we have discussed, these first bits in the class B will be 1 0 there, reserved for medium sized networks with the first 2 octets representing the network portion and the remaining 2 octets for the host portion there. Okay, example 172.16.0.0/12. Again, this 12 is used for the subnet mask, which is equals to 255 255.255.0.0. The default subnet mask for the class B is 255.255.0.0 there. Okay, now we are having a class C IP address. The class C IP address are used by a smaller organization or business that require fewer IP addresses. They provide around 234 hosts per network, making them suitable for small to medium sized business for dividing large networks into a smaller subnets there. Now again, as we are talking about this class C, so in the class C you will see that we are using the first octet A, and in the first octet the 3 bits are reserved, that is 1 1 0. Now we are left with remaining 5 1 2 3 4 and 5. So these 5 bits can have all zeros. Okay, so this is a binary number. I will multiply this by a 1, this 2 by a 2, this by a 4, 8, 16, 64, 32, 32 over here, 64 over here, and 128 there. So now we are having only 2 ones at these 2 positions, so I will add 128 plus 64, which is equals to 8 plus 4 112, 628 plus 1 9, 192. So now see that the value of A is starting from 192. Now we are remaining with B, C and D. So the initial address for the class C is 192.0.0.0. Okay, and the last address, and if we talk about the last address will be, the last address for this will be let me do it over here. This is 110, 5 bits, 1 2 3 4 and 5. So I can assign 1 1 1 1 and 1. Now again we will multiply this one by a 1, this one multiply by 2, this multiply by 4, this one multiply by 8, this will be multiplied by 16, this 0 will multiply by 32, this one will be multiplied by 64 and 128. And now where there are ones, we will add those all numbers. So 128 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1. When you will add them, we will get a number 223 there. So 223.255.255.255 will be the last IP address in the class C there. Now see that, as we have seen that the network address in the class C is given by that is total 3 octets, A, B and C. We are left with a D. Now in D we have total 8 bits. Okay, total 8 bits are there. So we are talking about the total number of hosts in the class C there. So as I told you, in class C there are total 254 hosts. Okay, so how there are 254 hosts? As we know, though, host in the class C is given by the last octet, which is having 8 bits. So 2 to the power 8 is equals to 254. 6 there. Okay, but we know that the initial 0 and 255 cannot be used for assigning the IP addresses. They are just used for identifying network, and 255 is used for broadcasting. That's why 256 minus 2, which is equals to 254 there. Okay, that's why the total number of hosts in the class C is 254 hosts there. Now again we are going to see that how many networks will be there. So as the 3 bits are reserved, we are now remaining with the 21 bits. So total 24 bits are assigned for the networks there. So the total number of address will be 2 to the power 21. Okay, these number of networks can be there in the particular class C there. So class C is used by the small organization or small businesses where there are few only devices which are to be assigned with the IP address there. Example 192.168.0.0 with a subnet of total this is wrong, by the default subnet for class C will be 255.255.255.0 there. Okay, the default IP address there will be, that is subnet mask. The default subnet IP address will be 255.255.255.0 there. Now the second last class, that is class D. The class D is used for a multicast purpose. What is multicasting? Multicasting is that when we are going to send a message to a group, so instead of giving that message to all the hosts in the group there, we are going to have a selected number of hosts in the network there. To them we are doing a multicasting. So multicasting allows one sender, that is one sender, to send data to multiple receivers simultaneously. Okay, so we are using those for streaming videos and for audio feeds there. Now the range for the class D is from 224.0.0.0 to 239.255.255.255. Okay, as you can see that how to recognize that this is a class D. We will see the first octet, and in the first octet if we found 1110 in the initial 8 bits, okay, then this belongs to the class D there. Reserved for multi-class addresses, used for many to one to many communication there. One to many communication means not to the all but to the selected ones there. Okay, then we are doing a multicasting there. Now talking about class E, the class E address are reserved for, that is they are reserved for experimental purpose and are not commonly used in a regular network configuration. These addresses are reserved for research purpose, development purpose and testing. If we are going to have some test over the internet, or we are doing some research work, then they are allocated for the general process. So how to recognize that this is a class E? We will see the first octet, and in the first octet the initial 4 bits are 1111, then this belongs to the class E there. The network range, that is the IP address range, will from 242.0.0 to 255.255.255. okay, reserved for experimental purpose and not meant for general use there. So this is about the class E there. Now let us have a summary of IPv4 classes there. So class A, network ID is given by total 8 bits, and it is identified by the first octet having a 0 there. Okay, so total host ID which are there, that is in bits, if we talk about total, that is 2 to the power 7 networks there, that is 128 networks are there, and we are having 2 to the power 24 bits which are used for the for the host there. So as I told you, this is about these much of number of hosts in a particular network can be there. Start addresses 0.0.0.0 to 127.255.255.255. Class B, the class B is identified by the leading that is 10 bits. Okay, how it is there? We are going to see that network ID bits are 2, A dot B dot C dot D there. So we are using these two for the network ID and these two for the host there. Okay, for the class B there. Okay, so total 16 bits are there, and out of 16 bits we have reserved 2 bits. Okay, we have reserved 2 bits, and these 2 bits are 1 0 there. Okay, we are talking about this 2 bits are 1 0. So now the total remaining bits are 14. 16 minus 2, the total bits remaining are 14. So 2 to the power 14 networks can be there, that is 16,384, and the remaining 16 bits are for the host there. So 2 to the power 16 hosts. Okay, but we will minus 2 from this number, so total number of hosts will be 65,534 there. So the starting address is 128.0.0.0 used for identifying the network, and 191.255.255.255 is used for broadcasting. So we are going to minus these two addresses from these total number of, that is 65,536 there. Now class C, the initial 3 bits are 110, and we use total 24 bits for the networks there. Okay, total 24 networks, and remaining 8 bits are used for the host there. So total networks is 2 to the power 21, which is approximately equals to 2,97,152 networks there, and in each network there can be a 254 host. Again, 2 to the power 8 is 256. We will minus 2. Why? 2 addresses, one is used for identifying the network, and the last address is used for doing the broadcasting in the particular network there. That's why total number of hosts are 254. The starting address is 192.0.0.0 to 223.255.255.255. Then we have class D, not used for the assigning the IP addresses, it is used for the multicasting purpose. The range is 224.0.0.0 to 239.255.255.255, and we have class E for the experimental purpose there. So this is about the IPv4 classes there, that is class A, class B, class C, and class E there. Now the conclusion of this particular lecture is that is the fundamental protocol for network communication supporting both IPv4 and IPv6. It operates at the network layer and uses the datagram approach for packet switching there. Connectionless communication means that packets are sent independently without establishing a prior connection. That is, dedicating up one particular line is not given in this particular protocol. We used a connectionless communication there. Now IP follows a best effort for delivery model, which makes it unreliable due to packet loss, out of order delivery, duplicate packets, delay in transmission there. Despite its limitation, IP is essential for global internet communication. Reliability is ensured by higher layer protocols like TCP, which manage error detection and flow control, and also the retransmission part there. And understanding IP address, subnetting, and routing is crucial for efficient network management there. Now the references which you can use for this particular IP is there, that is, these are the references which I have used, that is Kurose, Forouzan, computer networking, a top down approach, 8th edition. The publication is Pearson. Then there is another book, that is Tanenbaum, which is a very good book for the computer networks. Again, the publication is Pearson. And then we have a Forouzan there. For the research papers, you can go for a various IEEE and ACM publication on IP and networking. And online resources, you can go for Cisco Networking Academy, which is having a very good things about the computer networks. And also we are using a simulation model using a Cisco packet tracer for doing all these works there. So thank you, and have a good day there.